Okay, so follow me, okay, for the next test. Write it down along with me. It'll be your test, okay, Test-2.2C. This will cover under your exercise 2.2, question B4, I think. So this will find on textbook page 38. Okay, let's start with question B4, subheading 1. Let me read the question for us. Look into your text. Find the zero of the polynomial in each of the following cases. So 1, here we are given p of x is given as equal to x plus 5. Okay, we have to find the zero of this p of x, the expression x plus 5. Now we know this at the beginning of the chapter. I remember giving you this. Since for any zero of a polynomial, okay, the p of x value should be equal to 0. That is the basis on which we're going to do. The polynomial is equated to 0, p of x. So that would imply that p of x here, this one, same, which has a value of x plus 5, will replace this p of x. This equal is same, and this 0 on the right hand side is going to be unchanged. Okay, so here that gives you, now find the 0 means, in other words, 0 or root means the value of the unknown variable, and in this case the unknown variable is x. So 0 means the value of x in simple terms. So here plus 5 shifted to right side become minus 5, and plus 0 can be neglected because 0 doesn't affect the final outcome of a addition or subtraction, right? So therefore this minus 5x value is called a 0. The value of the unknown, usually x, or if it's y, that is called 0. So minus 5 is the value of the 0 of the polynomial p of x, means value of 0 of x plus 5 p of x is minus 5 is the answer. So that's the first answer. Then let's go to number 2. Here given to you is p of x is x minus 5. P of x is equal to x minus 5. So following the same procedure, we have to find the 0. The question clearly says find the 0 of the polynomial. So for that we have to write, since for any 0, that means any value of x, p of x should be equated to 0, is equal to 0. In other words, this p of x, which has a value of x minus 5, that x minus 5 will replace this p of x equal to 0. Then as we come here, find the 0 means, here the value of x. So keep the x unmoved and shift this minus 5 to the right, from left to the right side, and minus 5 becomes plus 5. Therefore plus 5 is the 0 of p of x. So this is our answer of plus 5. Same as book answer. And let us go to the third one. So the third one is here. Here the value of p of x is being given to us as 3, okay, 2x plus 5. So 2x plus 5. So since we know this is the basis on which we're going to do, since for any value of x or any x, any 0, p of x polynomial will be equal to 0. So that implies p of x, which is a value of 2x plus 5. So the 2x plus 5 will replace the p of x equal to right side, same 0. Then since 0 means the value of x, we take the term containing x unmoved, that is 2x, and shift this plus 5 to the right side, become minus 5 plus 0 means still minus 5. So we need not indicate the 0 anymore. So x will be equal to minus 5, and this here on the left side, 2 into x means if we shift 2 from left to right side, it will go to down to the denominator. Therefore, this value minus 5 by 2, I think same as textbook, is the required 0, or is the 0, or is the value of the 0, is the 0 of the polynomial p of x. Then number 4. Here, look at your question. P of x equal to 3x minus 2, I think. Yes. So following the same processes we have been doing for any value of 0, or for any 0, simply put, the p of x should be equal to 0. We know this from the beginning of the chapter. We discussed once, right, in the introduction. So that implies this p of x value here is 3x minus 2. So that 3x minus 2 will replace the p of x here, equal to right side is 0. Then 0 means the value of x, so the term containing x, 3x, is kept untouched, and shift this minus 2 to the right side, become plus 2. So x value, which is the 0, is 2. 3 into means shifted to right side will go down to denominator. Therefore 2 by 3, I think it's correct, yes, is the 0 means the value of x is the 0 of the polynomial p of x. Okay, this is the fourth one. And the fifth one. Let's go to the fifth one, question B4, subheading 5. Here, I think the value of p of x is given as 3x. Okay, that is clear. So, since for any 0 value, the p of x should be equal to 0. So that implies this p of x value, which is 3x, will replace the px here, will be equal to 0. So that will be x equal to 0 divided by this 3 into means shifted to right side will go down. And we know 0 divided by any number is always 0. Therefore, 0 is the 0 of p of x. Let's go to the sixth one. Okay. Sixth one is p of x. Here, p of x is equal to ax. Condition is given. In this case, a should not be equal to 0, means this value of a should not be equal to 0. Okay. For any value of 0, or since for any value of 0, since for any 0, the p of x should be equal to 0, which means this p of x value here, ax, should be equal to 0. As we proceed, x will therefore be 0 divided by and a into means if we shift it to right side, a will go down to denominator, so a here. Then 0 divided by anything, 0 divided by 2 or 0 divided by a, anything is always 0. Therefore 0 is the 0 of the polynomial p of x. Then the seventh one, the last one, I think. Here, the value of p of x is expressed as equal to the last one, cx plus d, cx plus d. However, there are some conditions mentioned. In this case, c value should not be equal to 0, question is saying. And the c and d value, small c and small d value, are real numbers. They should not be unreal numbers, but they should be real numbers. Okay, so since for any 0 following the same procedure, p of x value should be equal to 0. That implies this p of x here, small cx plus d, this should be small letter c, is equal to 0. No more space, I'm coming here, okay? 7th one. Sorry, excuse me. Okay, so here, that gives you here, that implies the term containing x is cx, so don't touch that. And then if you shift this plus d to right side, become minus d. So here, 0 is, essentially 0 means the value of the unknown x. So x, just give it alone, minus d. And if you shift this c into to the right side, go from numerator to down to the denominator. Therefore, minus d by c is the 0 of the polynomial p of x, the last one. Yes. So that concludes the part for test 2.2c. I hope that was clear, right? Okay.